In this lesson, I'm going to provide you with a quick summary of cloud operations, including the technical operations, data management, availability, disposable resources, monitoring and visibility, optimization, and managed service providers. Now, first, we need to talk about technical operations, and we'll quickly review the different cloud characteristics, cloud service models, and cloud deployment models that are utilized by organizations in the cloud. First, let's consider some of our cloud characteristics, including on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured services. Now, on-demand self-service means that your users can quickly and easily provision and manage their own resources, such as computing power and storage, without the need of IT specialized staff to manually provision those resources for the users. Now, broad network access means that the cloud resources and services can be accessed over the internet from anywhere as long as the end user has a valid internet connection. Resource pooling refers to the ability to share resources across multiple users and customers, while rapid elasticity refers to the ability to quickly and easily scale resources upward or downward as needed. Measured services is going to refer to the ability to monitor and measure usage of the cloud resources and services. Next, we have the three different service models in which cloud services can be delivered to your customers. This includes software as a service, infrastructure as a service, and platform as a service. The first service model is known as software as a service. Software as a service, or SaaS, refers to software applications that are delivered over the internet and are typically accessed through a web browser. Great examples of this include things like email, customer relationship management software, and human resource management systems. A great real-world example of software as a service is somebody who uses Office 365, which is a subscription-based online version of the Microsoft Office suite that can be accessed through a web browser. The second service model we have is known as infrastructure as a service. Now, infrastructure as a service, or IaaS, refers to the delivery of virtualized computing resources over the internet. This includes servers, storage, and networking. And a real-world example of infrastructure as a service is something like Amazon Web Services, or AWS, which is used to rent virtual servers, storage, and network capabilities on demand. The third service model we have is known as platform as a service. Now, platform as a service, or PaaS, refers to the delivery of a platform for customers to develop, run, and manage their own applications on top of. A good example of platform as a service is the company Heroku. Heroku is a cloud platform that enables developers to build, run, and operate applications entirely in the cloud. Next, we need to talk about cloud deployment models, which are the different ways in which cloud services can be deployed. This includes public, private, community, and hybrid clouds. Now, the first deployment model we have is known as a public cloud model. A public cloud model refers to cloud services that are made available to the general public over the internet. An example of a public cloud service is something like Microsoft Azure, where anybody can access these cloud services as long as they have a valid internet connection and they pay a fee using their credit card. The second deployment model we have is known as a private cloud model. Now, a private cloud model refers to cloud services that are only available to a specific organization or group of users. For example, we might create an in-house data center that only companies owned by Dion Training can use. This would be a private service cloud model. The third model we have is known as a community cloud. Now, a community cloud model is a deployment model in which a group of organizations share resources and infrastructure to deliver cloud services. A good example of a community cloud is where a consortium of different companies and organizations in one industry share a common cloud infrastructure. So, if 5 or 10 banks decide to work together to create a bank cloud, that would be a community cloud model. The fourth deployment model we have is known as a hybrid cloud model. Now, a hybrid cloud model is a deployment model that combines at least two of these three different types of models, whether they are public, private, or a community cloud. A good example of a hybrid cloud service might be a company that uses AWS as a public cloud while using their own private cloud internally in their data center and connecting the two together. That would then make this a hybrid cloud deployment since we're using both a public and private cloud. The second thing we need to talk about is data management. Now, data management includes replication, backup and recovery, data gravity, locality, data compression, data deduplication, and capacity on demand. Let's take a look at each of these. Data replication is going to refer to the process of creating multiple copies of data across different locations or servers. Backup and recovery solutions are going to refer to the process of creating and maintaining copies of data to be used in the event of some kind of data loss. Data gravity refers to the phenomenon where data tends to congregate in certain locations. Data gravity often occurs due to a variety of factors, things like network latency, data sovereignty regulations, or the cost of data transfer. Locality is going to refer to the location of the data and the impact it has on data management. This can include both physical locations, such as where the data center is located, as well as logical locations, such as which cloud region or availability zone that data is going to be stored in. Data compression involves reducing the size of data by removing redundant information, whereas data deduplication is a technique for reducing the amount of storage space required to store data by eliminating redundant or duplicate data. Essentially, the difference is, with data compression, you are crunching down the size of the file by taking out white space and other things that are redundant, whereas data deduplication is the entire file itself is only being stored once, and the other copies would then just be linked to the original file. Now, capacity on demand is going to refer to the ability to quickly and easily scale storage capacity as needed by your end users. The third area we need to talk about is availability in the cloud, and this includes the use of availability zones, regions, and geo-redundancy. Now, availability in the cloud refers to the ability of users to access and retrieve their data and applications from a remote network of servers over the internet at any time. An availability zone refers to the physical, separate, and isolated geographic location within a cloud provider's data center infrastructure. Each availability zone is designed to operate independently of the others, and each has its own redundant power and network connectivity to ensure that cloud services and applications that are running in one availability zone are not impacted by failures or disruptions in another. When we talk about a region, we're talking about a location for a particular cloud provider. For example, AWS has different regions, such as United States East 1 in Virginia and United States East 2, which is located in Ohio. Inside of these regions, though, there are multiple availability zones. Now, this brings us to the concept of geo-redundancy, and geo-redundancy refers to the process of creating multiple copies of data across different geographic locations to ensure that the data is available in the event of failure or outage in one of these other locations. This geo-redundancy allows you to place your data across multiple regions, and by doing this, you can also help comply with data sovereignty regulations because you're ensuring data is stored in the appropriate geographic location. For example, I might store all of my European customers' data in a European data center and all of my American customers' data in a US-based data center. Fourth, we have disposable resources. Now, the use of disposable resources is a major shift from traditional on-premise deployments because the servers were considered to be fixed resources in those traditional on-premise deployments. With cloud computing, though, virtual servers are treated as disposable resources, which can be created and destroyed whenever you need them. This has brought numerous benefits to organizations, such as reduced costs, efficient resource utilization, and the ability to respond quickly to changing demands. Fifth, we have monitoring and visibility, which are achieved through alerts and logging. Now, alerts are notifications that are triggered when certain conditions are met, such as high CPU utilization, low disk space, or failed login attempts have occurred. These alerts can be sent through various channels such as email, text messages, or push notifications to your smartphone, and they're designed to notify administrators of potential issues so they can then take action to resolve them. Logging, on the other hand, refers to the collection and preservation of information about the operation of a given system, including system events, application logs, network logs, license utilization, updates, upgrades, and compliance with SLA and regulatory requirements. All this information can then be used for troubleshooting, performance monitoring, or tracking changes by going through the logs. Sixth, we have optimization. Optimization in cloud computing refers to the process of adjusting and fine-tuning various elements of a cloud infrastructure to improve performance, reduce costs, and ensure high availability. Optimization involves three key components: autoscaling, right-sizing, and load balancing. Now, autoscaling is the process of automatically adjusting the number of computing resources based on the demands that are being placed upon them. Right-sizing, on the other hand, refers to the process of optimizing resource utilization by allocating the right amount of resources to each application or service. Load balancing is going to be the process of distributing computing resources across multiple servers to ensure that resources are being used effectively and efficiently. Finally, we need to talk about managed service providers. A managed service provider, or MSP, is a company that provides outsourcing services for various cloud computing tasks and responsibilities. Managed service providers offer comprehensive cloud support management services, including network and infrastructure management, security, and data backup and recovery, as well as many others. So, for the exam, it's important to remember that cloud operations, including technical operations, data management, availability, disposable resources, monitoring and visibility, optimization, and managed service providers are different things that your organization can use when they're operating in the cloud to be more effective and more efficient.